Hi everyone and welcome to Nortech's VRF Foundations Model V5 training class. Our goal today is to learn more about how VRF systems work, in particular Nortech Global HVAC's V5 VRF system. We'll cover how to lay out a system and what it takes to install a V5 system. We'll break this presentation down into two sessions. After each session, there will be a Q&A portion where I'll answer the questions you submit during the presentation. You can submit questions at any time by clicking on the Ask a Question button below the video player on your screen. I know you'll ask some great questions, and I'll answer as many as I can during our limited time frame. If I don't get around to your questions, I'll email you the answer after the course is completed. We've introduced this first of many technical presentations to better serve our customers. We'll cover basic design, installation, and commissioning in this class. I hope this will give you an idea of what is needed to support these products, as well as serve as a launching point for more in-depth instruction. Speaking of in-depth instruction, an installation and commissioning class that includes hands-on learning will be offered this fall at our training facility in O'Fallon, Missouri. After our class is over, pass this information on to your team about this class and future classes so they can benefit from the knowledge and move on to the hands-on training we'll offer in the fall. Before we truly begin, I'd like to introduce myself. I'm James McIntyre. I'm originally from Alabama, but currently call Dallas-Fort Worth home. With the exception of a 4-year stint in the U.S. Navy, I've spent my entire life in the HVAC industry. I started as free labor for my father's HVAC business and then became an installer and service technician. After that, I worked as a tech support and field engineer at a VRF competitor for 2 years. Then I spent 2 years as a field engineer at a data and precision cooling manufacturer, a couple of years as a service tech for a commercial contractor, and a couple of years at yet another VRF competitor. There, I worked in a tech support capacity and became a technical trainer. Now I work at Nortech Global HVAC as the VRF training manager. Here at Nortech Global HVAC, we offer great products I stand behind. But what I believe to be true, and my experience has proven, is that a company can offer the best equipment in the market for the lowest price, but if it doesn't fully support those products, then that company will not be successful. Their customers will go elsewhere, and I can't stand to see that happen. We are going to support this equipment with training, technical, and sales support found nowhere else in the country, particularly in the VRF market. Each one of us on the technical team knows what it's like to be caught in the field with no help. We're going to do everything we can to ensure that this does not happen to our customers. Now, let's begin. In a traditional system, the compressor is either on or off. This means that the system is operating at full capacity regardless of how little heating or cooling is needed. Not the most efficient way to heat and cool a given space. Manufacturers have known this for years and have tried to mitigate this inefficiency by using multiple compressors. Some have tried to stage multiple compressors, like in a 60-40 split, meaning that it can produce less than 100% capacity, but not really dial into what is needed. This is similar in function to an unloader type system that effectively cycles on and off the pumping mechanism of the compressor relatively rapidly. The use of thermostatic expansion valves enables the system to achieve capacities closer to what is required, but the compressor is still running at very close to its rated capacity. With the addition of multi-speed fan motors, the air can be slowed down to reduce capacity, but the compressor still operates pretty close to 100% of the required load. All of these improvements combined with ever larger coils will give you a little more energy efficiency, but a much more expensive system. The best, most energy efficient way of meeting load requirements is by varying the refrigerant flow. This is where VRF gets its name. Using a combination of truly variable speed compressors and fan motors, coupled with electronic expansion valves, you get the most energy efficient solution in the HVAC industry. So we ask, what exactly is VRF? A VRF system is a heating and air conditioning system consisting of one or more outdoor units coupled with multiple indoor units. You can see an example below. Just to point out, the red line in the case of this heat pump type VRF system represents both a liquid and gas line. The system can increase or decrease the speed of the compressor as the system needs more or less refrigerant. Note that 3 of the indoor units are heating. As the overall system load increases, or as more units require a greater volume of refrigerant to heat or cool, the compressor speed will increase, gradually meeting the capacity that the space or building requires. In simpler terms, if I need more cooling, I get more cooling. If I need less, I get less. And my power bill is cheaper because of it. That makes me a happy customer. Now, I've always been a technical person. I suppose that also makes me pretty skeptical. When I started in the VRF portion of this industry, I was skeptical too. One of the questions I had at the time was, if this system is so great, why am I just now hearing about it? That was in 2008. That's not really that long ago. Let me ask you this, and you let me know if you got your answer right, or lie and say you did during the Q&A. How long do you think VRF has been around? You folks remember Madonna and Michael Jackson on the radio? How about Ronald Reagan being president? E.T., the Apple II? Many of you weren't in HVAC back then, and some of you may not have even been alive. Well, the first VRF system in the world rolled off the assembly line in 1982, over 34 years ago. Since then, the system design has gone through many improvements, much in the electronics department. But if it's been around so long, and it is so great, why isn't VRF everywhere? The short answer is that it is everywhere. VRF and inverter-driven ductless systems are the most common systems worldwide. If you've been overseas, you've seen similar products everywhere. And even as uncommon in the U.S. as we think VRF systems are, the U.S. ranks fourth in global markets. According to the Building Services Research and Information Association, we can expect an 11% growth rate yearly in VRF market share. Much of the market share gains, as you'd expect, are from small and medium-sized chillers. This is what an 11% growth rate looks like on a chart. I like charts. Let's discuss the advantages of a VRF system. As we discussed, it is the most energy-efficient HVAC solution. With a V5 system, you have true zoning capability and the ability to meet partial load requirements. This leads to better comfort. These systems require less installation space when compared to many traditional HVAC solutions. And a V5 system's flexibility is hard to beat. Charts are fantastic, right? In a traditional system, it operates at full capacity regardless of the changes in load. In a V5 VRF system, the system meets the load requirement throughout the day. The Department of Energy's Energy Star program estimates that 75% of the time, a properly designed system operates at 70% of its full capacity. In other words, 3/4 of the time a properly designed system's running, it only needs 70% of its full capacity. So that's real energy savings. Some of our competitors use a combination of inverter-driven and standard compressors. But in our system, we use nothing but digitally commutated inverter compressors. This gives us an advantage over traditional systems in that we can operate all the way down to 10% of the system's total capacity. In real-world terms, a 10-ton unit can produce only 1 ton if needed. Imagine the savings in a building where the load varies, which is very nearly every building. Another advantage of all inverter DC compressors is the lack of locked rotor amps found in standard compressors. This means less stress on the equipment and less load on the building's electrical system. This also means that these systems are more easily integrated with a generator or off-the-grid power. In addition to digitally commutated compressors,